Now we have our youngest friend, energetic, knowledgeable, assistant professor of Department of Silviculture, Agroforestry, College of Forestry from Thrissur, Kerala, Dr. Jijesh CM. To say a few words about him, he has his BSc in forestry in 2001 from Kerala Agriculture University, Thrissur. MSc in silviculture and agroforestry in 2004 and has his doctorate, that is a PhD silviculture in 2014 from Forest Research Institute, Dehradun, Uttarakhand. He has publications of about 56 research papers, 32 papers in seminars, conferences, workshops, and he has 7 book chapters and also 2 edited research books at his credit. His major research areas are on major crops like teak, bamboo, and sandal. He has also good exposure in reproductive biology, seed and nursery techniques, plantation establishment, litter dynamics, biomass production, and carbon sequestration. Being a young scientist and faculty of the university, we wish him all the best of luck in all his endeavors in future. Now I request Dr. Jijesh Ji to address us on carbon sequestration and soil improvement through bamboo cultivation. Thank you.
Thank you, sir. Thank you for the nice introduction and wishes for my future. So the topic for the day is the carbon sequestration and soil improvement through the bamboo cultivation. My presentation will be like this. That is I will give an just introduction about bamboo and the global climate change, the biomass production and carbon sequestration potential of bamboos, the soil improvement through the bamboo cultivation. And I think I may not introduce bamboo too much. Bamboo is useful both rich and poor equally. Grows from sea level to mountain tops. It can tolerate drought, flooding, and frost. And it is endowed with more than 5,000 uses, and the uses are increasing day by day. And the property-wise, bamboo is as flexible as a lady and as strong as a man. And it is a member of the Poaceae, and worldwide there are around 1,662 species in 121 genera. And if you look into the Indian scenario, there are 26 genera and 156 species are present in India. And also, all of you know, the global warming and its associated climate change is one of the greatest challenges of the millennium. And the emission of carbon into the ecosystem due to industrial and technological advancement is one of the strongest causal factors of the global warming. So the climate change that considers the changes that occur to climate in long period of time. The climate is the average weather conditions of the area. If there is changes in the climate for very long time, then only we consider it as a climate change. So the climate, we all are experiencing the bad effects of climate change. Our temperature has risen and it has affected the productivity. So we have to control this global warming and associated climate change. So there are many options. 3 options are available. One is the mitigative option, the adaptive option, and indirect options. The mitigative options include the carbon sequestration and emission reduction. The adaptive options, that is the adjustments in ways that will reduce the negative impacts of temperature, and the indirect options like controlling the population growth or changing the technology. The bamboo can play a major role in the mitigative option as well as the adaptive option. Bamboo can contribute to the carbon sequestration, and it is a climate resilient crop, so it can be used in the adaptive options also. So I am not discussing much about the impact of climate change. Even then, if you look into the agricultural productivity, you can see the low latitudes, the crops in the low altitudes. If the temperature is increasing, definitely there will be negative impact of the temperature. It can reduce the yield of low altitude wheat, rice, and maize even up to 40% if the temperature is increased by 3 degrees Celsius. If you look into the India's intended nationally determined contribution, the INDC, the commitments are like this. India has to reduce the emission intensity of its GDP by 33 to 35% by 2030 from the 2050 level. We have to reduce the emission intensity. Also, we have to create the additional carbon sink of 2.5 to 3 billion tons of CO2 equivalent through the additional forest and tree cover. So we have to go for the sequestration of the carbon in the biomass by 2030. Already our forest, the natural forest, we can go for the increase in the area, and it is in the agriculture systems and the trees outside forest area. We can go for the expansion of the tree cover, and here the bamboo can play a major role. So all the strategies developed by India, like National Agroforestry Policy, Green India Mission, Red Plus Policy, Joint Forest Management, National Afforestation Program, in all these programs, bamboo can play a major role. So the Kyoto Protocol allows the clean development mechanism. So the clean development mechanisms aims at bringing funding from the Annex 1 countries for the environment friendly projects in the non-Annex 1 countries. All of you may be knowing about the Kyoto Protocol. So the Annex 1 countries will earn the certified emission reduction credits, so they can continue to emit. And this brings the concept of carbon trading, which allows the developed countries to transfer the emission credits to each other countries that reduce the emission more than the national target under Kyoto Protocol. So the bamboo also can take part in the carbon trading. So coming to carbon sequestration, the IPCC, International Panel on Climate Change, 2000 defines the carbon sequestration as an increase in the carbon stock in any non-atmospheric reservoir. If the carbon is stored in any non-atmospheric reservoir, it is called as the carbon sequestration. But in detail, we can see the carbon sequestration. It is the long-term storage of carbon in oceans, soil, vegetation, especially in forests, and the other geological formation. So it is the long-term storage of carbon. The carbon storage should be long-term, and the carbon sequestration through biomass seems to be a cheap and viable option to mitigate the global climate change. So the sequestration through biomass is important. If you look into the advantages of bamboo in carbon sequestration, All of you know the bamboos, they are the arborescent grasses belonging to Poaceae. They are with a high economic and environmental values. When you are going from the bamboo plantation, there is environmental benefits and the farmer is also getting the returns. So that is why bamboo is very important, and it has the potential to cover the solar radiation into useful products, goods and services better than many other tree species. And if you look at the distribution of bamboos, it is having a cosmopolitan distribution. It is growing in tropical, subtropical and temperate regions except Europe. And the bamboo is having a large species diversity, and the overall around 1,600 species of bamboo are grown in different parts of the world. This species diversity allow it grow in the any part of the world and to tolerate climatic exigencies. So various number of various species are available, and different growth forms of bamboo such as trees, shrubs and climbers are also found naturally. And it is observed as pure stand. It can grow as the pure bamboo stand mixed with other species, and also cultivated in homesteads, farmlands and other agroforestry system. If you look into the bamboo physiology is conducive to higher productivity and substantial carbon removal from the atmosphere. The bamboo has a high productivity and the physiology is conducive for the growth. Bamboo, like the trees, are C3 plants. Bamboos are today, they are grasses, but they are having a C3 pathway of the photosynthesis, not the C4. And they are endowed with relatively low photorespiration and high photosynthetic efficiency, and with around 0.3 to 5.3% of ash, bamboo approximate the tropical tree species, and they contain more ash than the temperate woods. So the bamboo physiology, if you look into the bamboo physiology, it is all good for the better growth of the bamboo species compared to other species. And the bamboos are effective carbon dioxide absorption. Bamboo can absorb the carbon dioxide, and it can be stored both in the above ground and below ground. And the below ground parts, the roots and rhizomes, can store the bamboo, and the bamboos can even grow at the rate up to 1.2 meters per day. And it requires less time for maturity and harvest compared to other timber species. And the impressive biomass derives from the energy produced before and stored in the rhizomes or clumps. So every year there will be new shoot production. A prolonged carbon sequestration of its carbon is provided by its numerous bamboo products if protected against deterioration. If you have to protect the bamboo products against the deterioration, and some of the risks associated with the carbon sequestration of bamboos are the individual clump has a life cycle of around 7 to 10 years. Normally the clumps have a life cycle of 7 to 10 years, and thereafter, like any other biomass, it will disintegrate and it will produce the carbon dioxide. And the gregarious flowering is of many species after some decades, followed by their death, provides a massive carbon dioxide absorption. The bamboo flowering, if you look into the peculiarity of bamboo flowering, in bamboo, the gregarious flowering, that is, or the mass flowering, or the flowering at the entire area can occur, and that will lead to the death of the clumps, and as a result, there will be massive carbon dioxide exposure. And bamboo has the large capacity for biomass accumulation within a short period and a high potential for the carbon storage. The bamboo biomass, the bamboo litter, and bamboo soil act as the carbon sink in the forest ecosystem. So the CDM Executive Board in its 39th meeting decided that palms and bamboos are equivalent to trees in the context of afforestation and reforestation CDM. So the bamboos were not included in the CDM activities till then. And following this act, the Food and Trees for Africa, the program Bamboo for Africa program has been certified under the verified carbon standard, and it is the first accreditation of bamboo in the world. So one of the issue is the long-term storage of carbon. If you look into the use of bamboo, we can see there are many uses, more than 5,000 uses are recorded for bamboo. And as already discussed, the carbon sequestration is the long-term storage of carbon. And you can see, I think more carbon is stored in the below ground compared to the above ground, because the bamboo rhizome will grow for more years than the clumps. And if once the bamboo is used for the manufacture of durable products, the carbon sequestration will occur. So this is the consumption pattern of bamboos in India. The common use, the main use, it is used for pulp, housing, and non-residential uses, and wood-based industries, furniture, etc. All these uses are not that much durable. So the most nutrition value-added bamboo products like the composites, the wood substitutes like bamboo mat board, bamboo mat, corrugated sheets, flattened bamboo boards, laminated bamboo flooring. All these products are highly durable, and a substantial amount of carbon can be stored in these long-lived products. And the products like bamboo charcoal and bamboo biochar is another potential carbon stock. We are using the biochar for potting as the component of potting mixture. You can see that the carbon, they can remain in the soil for thousands of years. And so the carbon can be stored for very long time. And if you look into the manufacture of most of the bamboo products, you can see that bamboo can support the low carbon and sustainable products. And the manufacture usually requires much less energy than the comparable fossil fuel based products, which means that a bamboo based industry can indirectly reduce the carbon dioxide emissions. So these are requiring the less energy compared to other products. And the life cycle analysis of bamboo products indicate that they are carbon dioxide neutral or better. And through the modern engineering techniques, bamboo products may become more durable, therefore able to store carbon for the longer periods. Thus, bamboo can contribute greatly to future low carbon society, while also helping to conserve and restore the forest resources. And all of you know about the vegetative growth of the bamboos. The most of the bamboo species grow vegetatively for a long period by producing the new shoots every year, and the period of vegetative growth varies from 3 to 120 years. And thereafter, there will be flowering. And this flowering is completed by 3 to 4 years. And after that, the entire clump may die. So if you look into the growth of bamboo, that is exponential. Every year, new set of clumps are produced. That is the growth of new shoots in bamboo clumps occur as a result of transfer of energy accumulated comes through photosynthesis in the previous year. And the bamboo has several advantages over tree species in terms of sustainability and carbon fixing capacity. Inverse has stated that the bamboo biomass and carbon production may be 7 to 30% higher compared to the fast growing woody species. So this is the comparison of the biomass production by bamboos and Dendrocalamus strictus. Here you can see the growth of bamboo is higher even compared to the fast-growing tree species like Casuarina equisetifolia, Eucalyptus terticonis, and it has a higher growth biomass production compared to teak and grevillea. So bamboo has a highest capacity for the biomass production, that too in a short time. If you look into the biomass production of bamboos, only limited studies are available. The studies on the biomass production of bamboos is lacking. Actually, all of us are interested to know how much bamboo comes you will be getting, how much biomass you can produce, but the studies are limited. And at international level, most of the studies are limited to monopodial bamboo species, which are structurally different from the sympodial bamboo species. This is the compilation of the sum of studies at international level. Here you can see the species like Cheskia gulo, the Dendrocalamus hamiltoni, and Philostachys pubescens. They can produce a larger biomass around 150 more than 100 ton per hectare. The species specific variation is obvious in all these studies. The location specific as well as the species specific variation is found in the biomass production of species. If you look into the studies in the Indian scenario, most of them are focused on our common bamboo species, the Dendrocalamus strictus and Bambusa bambus, among which the Bambusa bambus is said to have a higher biomass production around 297 ton per hectare, and Dendrocalamus strictus 74.7, Bambusa balcova 140, and Bambusa pallida 114, and many other studies also indicate the higher biomass production by the species, and the Nath and his co-workers has studied the biomass production of a stand constituent Bambusa cacharensis, Bambusa balcova, and vulgaris, that is around 131.51 ton per hectare, and there are many other studies also. So if you look into the different methodologies used for the biomass production studies, most of the studies are based on some assumptions. Some of them are sampling the clumps for biomass. They will be selecting the clumps from different diameter classes, and they will be obtaining the dry weight biomass, and this will be extrapolated for the total number of clumps per hectare. And some studies are classifying the bamboo clumps into age classes, and the representative samples are harvested from each age class, and the biomass is determined and it is applied to the total population. And some of the studies have evolved the allometric or the regression equations, and they are using these allometric equations for the prediction of biomass in their area. However, whenever you are using these allometric equations, there should be some ground truthing, or we have to harvest at least a few clumps or clumps to apply these allometric equations. And another method is the destructive sampling. You can destructively sample the clumps, and the below ground studies of below ground part, the root and rhizome biomass studies are very scarce in most of the cases. So the carbon sequestration, regarding the carbon sequestration studies, Nath and co-workers reported that the carbon storage in a stand consisting of Bambusa cacharensis, Bambusa vulgaris, and Bambusa balcova is around 120.75 ton per hectare. of which the soil contribute 57.3 ton per hectare and the above ground biomass 61.05 and the litter contribute 2.40 ton per hectare. And there is another study by Agarwal and Purwar on the carbon storage of different bamboo species. And since 2009, the studies on bamboo carbon sequestration have been continuously carried out by our research groups. And we have studied around 6 species for their biomass production and litter dynamics. The species like Bambusa balkova, the Bambusa bambus. Bambusa bambus is a thorny species, Bambusa balkova, non-thorny species, which are large clump forming bamboo species. The Stachys oliveri, which is the most preferred species by the bamboo farmers in Kerala, and the endemic species, the Ochlandra travancourica and the Manrokova richae and Ochlandra setigera. The biomass production of first 4 species were studied under the plantation conditions, and that of Manrokova richae and Ochlandra, the studies were in the natural population. So we'll quickly go through the results of the biomass production and carbon storage in different bamboo species. Here you can see the total biomass production per hectare of Bambusa balkova is around 70 ton per hectare at the age of 7th year. And the carbon storage is 30.66 ton. And the oliveri also has considerable biomass, and the Manrokova richae and Ochlandra setigera has got the highest biomass. They are in the natural populations, and we don't know the actual age of the plantation, but they are able to sequester more carbon. And we have used the destructive sampling for all these studies. Representative clumps were harvested for each year, and we have studied the biomass production and carbon sequestration, and we have evaluated the carbon concentration of the different bamboo species. And you can see there is difference in the carbon contents in the clumps, the branches, leaf and root and rhizome. Rhizome is having a low carbon content. Even in the clump, there is difference in the position due to position of the clumps, and around 45 to 40% of carbon is found in the biomass components. So if you look into the difference in the biomass production of this species, you can see the Bambusa balkova having the number of around 13.58 tons per clump. Bambus, it is around 19. In Ochlandra travancourica and the Manrokova richae and Ochlandra setigera, there is large number of clumps occurs per clump. This might have attributed to the differential biomass production by different species. Even if you look into the allocation of the biomass in the clump components, mainly the clumps are contributing more to the total biomass. So in these 4 bamboo species, you can find the difference in the nature of bamboo species. Herein you can see the Bambusa balkova. Here Bambusa balkova is a branching species, branching from below. Here the branch constitute around 21%. Whereas in Stachys oliveri, which is branching from the top, here the clump contributes more biomass, more to the total biomass. And if you look into the Manrokova richae and Ochlandra setigera, we don't know the exact age. There the rhizome equally contribute to the total biomass. The contribution of stem and rhizome is equal in Manrokova richae. And also in Ochlandra setigera, the rhizome is contributing substantially to the total biomass. We have also estimated the soil carbon storage under different bamboo species. And we have done it at different soil depths, 0 to 20, 20 to 40, 40 to 60. And you can see around 56, around the bamboo balco have around 56.95 soil carbon storage. The natural population definitely have a higher carbon storage compared to plantation. You can see here the values comes to around 84 and 117. So we in carbon sequestration, we are estimating mainly the above ground and below ground compoundings, but we are not estimating the soil carbon sequestration, which is higher in many species. And this studies on soil carbon sequestration is very less. And Northern Coworkers has reported that the soil carbon stock of bamboo plantation were at a depth of 30 centimeter was 57.3 ton per hectare. And Therial has reported the soil organic stocks in the plantations of Dendroclamus strictus, Bambusa bambus, and Bambusa vulgaris, Bambusa balcova, and Bambusa vulcan. Bambusa newtons was to the tune of 105 to 105.56 ton per hectare and 57.25 ton per hectare. So the soil carbon sequestration also is to be considered in this context. Now I will go to the soil improvement through the bamboo cultivation. All of you know the litter fall plays a significant role in the nutrient cycling of the tropical ecosystem, and the plant litter acts as a temporary sink for the nutrients and functions as a slow release of nutrient source. And it is estimated that the litter nutrients released by the litter decomposition make 70 to 90% of the total requirement of the plants. So the litter dynamics is very important in especially in our ecosystem. And if you look into the bamboo, you can see the most of the bamboo plantations are distributed in the nutrient poor, degraded lands or marginal lands. Here bamboo can grow in bamboo also can grow in relatively poor soil and efficiently make use the available nutrients and build up relatively fertile soil around the clumps. So bamboo, most of the bamboo species are grown in the marginal lands. And so on degraded soils, the litter fall and fine roots of bamboo adds considerable amount of carbon and nutrients into the soil, which helps in the improving the soil health. So there are numerous studies on the litter dynamics of the bamboo species. The studies on Bambusa balcova, Bambusa bambus, Bambusa pallidon, Dendroclamus strictus by different authors, and so many other studies have been carried out. And we have conducted the litter dynamic studies in the all 6 species, and we have found that the average litter production of bamboo species vary from 5 ton to 1.981 ton. So in species, the Bambusa balcova and Bambusa bambus and Ochlondra travancourica, here you can see the highest litter production is found in the Bambusa balcova and oliveri. All other, the litter production was less. And in Mandroclava, Riche, and Ochlondra travancourica, the litter production is around 2.8 and 1.98 ton per hectare. So the litter traps were used to study the dynamics of the litter. And if the litter production dynamics of the different bamboo species are given in this graph, you can see the litter production follows a bimodal pattern. That means there will be two peaks, and the highest peak will be around March. In March, there will be high production of the litter. And similarly, you can see the litter production of Riche and Oclandra setigera. So the litter production, it is spread throughout the year in all the species. And considerable litter accumulation on the flower started during the winter season, and it was at peak during March, and litter production pattern was bimodal with a major peak at March in all the species. And if you look into the litter decomposition studies, the mass loss rates were all rapid in the early stages of decomposition of all the species, but it slowed down later. And the relation between the time of incubation, we have used regression to connect this mass loss, and the litter mass expressed as the percentage of original dry mass decreased exponentially over the time. So we studied the litter decomposition of the species. In all the species, you can see the litter decomposition or the mass loss is very fast initially. Thereafter, it will decrease, and this trend is also seen in all the species. And here we have calculated the decomposition rate and the constant and the decomposition periods of the different bamboo species. You can see in Bambusa balcova, it takes 3 months for the 50% mass loss, and in Bambusa banzibus, it is 63. In oliveri, it takes around 77 days for 50% mass loss, and in Mandrakova Riche also 77 days, Oclandra setigera 89 days. So within the 3 to 4 months, the half of the litter mass was decomposed. And if you look into the decomposition of the litter mass of other tree species in Kerala conditions, you can see they are having a higher K value, and the half-life is higher or almost comparable with the bamboo species. And we have studied the nutrient release dynamics of decomposing litter, how the nutrient is released from the nutrient of the decomposing litter. Then in general, the nutrient release was faster in the initial phases of decomposition. So we already stated that within 2-3 months, 50% of the litter mass loss occurs, and the nutrient release was also synchrony with this, and there was an initial faster release and accumulation at different stages, and a final release in the all species. And you can see the order of release was the most released element was the magnesium, and the least was the potassium. And we have compared the nutrient release period for the different bamboo species. Here also you can see all the nutrients like NPK, calcium, magnesium, all these are released within 2 to 3 months. There is species specific variation in this nutrient release. However, within 2 to 4 months, there is 50% release of the nutrients. And many other studies are also in the same line. The Kushal et al. 2000 has studied the effect of bamboo on the soil improvement, and they have found that the litter fall of this species ranges from 8.1 to 12.4 megagram per hectare. And among the soil physical properties, significant improvement were recorded in the hydraulic conductivity, water stable aggregates, and the mean weight diameter, and the soil pH, the organic carbon, available phosphorus under the different species did not reveal any significant changes, while significant reduction was observed in the total nitrogen and potassium. So, to conclude, most of the bamboo species can accumulate substantial biomass, amount of biomass in their clumps. And these bamboos can sequester considerable amount of carbon in their biomass, and the high biomass productivity and carbon sequestration of the bamboo species suggest their potential use in the eco-restoration of marginal and degraded lands, and those can contribute to the carbon sequestration potential of the terrestrial biomes. On a financial point of view, bamboo can play a major role in carbon trading under clean development mechanism and further global mechanism like RED and RED+. So including bamboo in this mechanism will enable the country to generate some income also. And its inclusion provides access to the global carbon funds and initiative to grow the more bamboo. And with regard to litter decomposition, in all bamboo species, two phases of heavy litter fall occurred, first in winter season and then in summer. And decomposition studies indicated that the litter decomposes its half of to original mass in the initial 3 to 4 months, that is during the southwest monsoon season. And as you may be knowing, the recruitment in the bamboo species occur with the onset of monsoon in June, or in the pre-monsoon showers in May. The litter decay synchronizes with the growth of the new clumps. And most of the bamboo species will reach their maximum dimensions in the first 4 months. So this will be enough for, they can supply the nutrients for the bamboo growth. And the later slow release of nutrients can accumulate or accumulate if any new clumps emerge during the northeast monsoon. And if you look into the literature, you can see the intercropping can be practiced in the bamboo in the initial stages of establishment. Thus, the slow release of nutrients from the surge of litter fall in October, November may facilitate the summer cropping in April, while the second peak in February makes the nutrients available for the monsoon cropping in July. The slow rate of decomposition of bamboo litter on the soil surface indicates the potential of litter to be used as an organic mulch to conserve the moisture of agriculture soils. However, we have to evaluate the allopathic potential of bamboo litter before using it as a mulch material. Thank you everyone for patiently hearing me.
Thank you, Dr. Jijesh. That was a very wonderful and detailed presentation. You have you broke down the components of carbon sequestration for us in a very simple way. Thank you very much. And move on to a few questions. There's a question from Dr. Mukta Chandra Das. Kindly explain about carbon budget and role of bamboo.
Pardon?
Kindly explain about carbon budget and role of bamboo.
The role of bamboo in
carbon budget and role of bamboo. I think this is relevant. You already covered it.
Yeah, that I have discussed in detail, I think.
Yes, yes.
Actually, I was discussing about the carbon budget of bamboo. Bamboo has the, in nutshell, we can see the bamboo has a higher biomass production,
okay,
and around 40 to 50% carbon is found in the bamboo components, and around 40 to 50% of this biomass is carbon. And if you take into consideration the carbon dioxide potential, these values can be higher, which has to be multiplied by 3.6.
Okay.
Anything more to explain?
1 second, sir. There's one more question from I think that Dr. Bharti is answering that. Okay. Which bamboo variety has most commercial value? I think Dr. Bharti or you can answer this.
Which bamboo varieties most commercially?
Yes, has more commercial value.
That is regarding the commercial utilization or in monetary point of view?
Yeah.
Yeah.
Yes, sir. Yes, sir.
Tulda.
Sir, I should say that depends upon the location.
Okay.
Definitely species specific and location specific variation occurs in the growth of the bamboo species also.
Okay.
And in some places, there are peculiar uses for the bamboos.
Okay.
I think the fisherman uses the Thistostachys oliveri. And the farmers nearby are getting around 1,000 rupees for one cum of the Thistostachys oliveri. But in another different situation, the value the financial point of view, the value may vary.
Okay, next question, sir. What is the potential of creating and selling of carbon credits for individual farmers?
Definitely, in the initial stage of the Kyoto Protocol, I think we have the joint implementation of projects and the CDM. And there the carbon trading was prominent at that time. That time around 36 euro for the 1 unit of carbon. That is around, the price was around 36, but it is reduced to even 4 euro. And now because of there is no much commitment from the countries, I think in future, there may be opportunity for the carbon trading.
Okay, moving on to next question. How biomass value can be converted into carbon value? What is the formula?
Pardon?
How biomass value can be converted into carbon value? What is the formula?
I should say so many people are using around 50% biomass contains carbon. That is an assumption, but it is correct. But we can find the actual carbon content of the different biomass components, and we can find what is the correction factor, and we can multiply to find the carbon sequestration.
Okay. Thank you very much.
Anything, Bharat, you want to add?
Yeah. Dr. Bharti, would you like to add anything else?
Yeah, excellent presentation of him, and then superb. He has taken up a PhD in bamboo carbon sequestration, which is actually very good. This is what the need of the hour. Lot of people are not aware of this information, whatever Jijesh has spoke today, and a long good future is there for this particular subject.
Okay, sir. Thank you. And I would like to invite Dr. A.C. Lakshmana to speak a few words.
Am I audible?
Yeah.
Yes, sir.
You are very much audible.
Oh, thank you very much. First of all, I would like to congratulate the BSI chairman, Mr. Sundar Naik, and his team for inviting all of us to a very scientific exposure of bamboos. The speakers, different experts from different faculties addressed us. It was very interesting, and new vistas are open to us. So I congratulate the BSI members for this. Then dear Gurpreet corrected, he covered a lot of practical aspects of bamboo cultivation. And he being a businessman, he knows how to grow what is economical to the people and how to recommend also. I congratulate him also. And Dr. Jijesh is a budding scientist, a doctorate in bamboo subject, and I welcome him and wish him a bright future. And our old horse, Dr. Bharti, stole the show today. He gave an entirely a new dimension to the bamboo. And actually, I was also able to update my own this thing about bamboo because I presented an article at an international workshop in 2004, the impact of bamboo in silviculture, where one degree temperature was reduced in the area, and 35 degrees was the increase of increased productivity of water along with other economical returns from the produce. But his presentation today has added a new dimension to my own thinking of 2004. I congratulate him because he has opened the eyes of all of us for a new dimension. Compliments to you, my old horse, Dr. Bharti.
Thank you, sir. Thank you. Thank you, sir.
And my own suggestion to the State Planning Commission in Mysore, Karnataka, that he suggested that the head of the department should earmark 2% of the total allotted funds for innovative and research work, and it is accepted in principle in Karnataka. Only thing is we'll have to see when these political heads will give it in the form of an order to all of us. If that comes true, that will be very nice for us. Anyhow, I thank all of you and all the participants for patiently attending this, the present webinar today. I compliment all of you. Thank you all very much. Thank you.
Thank you, sir. Thank you for your kind words. And
Did you hear completely?
yeah, no, we heard you. We heard you, sir. Thank you.
Okay.
Thank
Because
you.
there was silence, I thought, you have all deserted me. Thank
No,
you.
sir. No, sir. No, no, no. Thank you.
Thank you.
Thank you. Ladies and gentlemen, thank you very much for your patient hearing. I hope this session was useful. Dr. Jijesh, thank you very much for your wonderful speech.